I'm going to try to do a short video here, and I admit I'm rushed for time. There were some comments about the video I did on the impedance analyzer for the analog discovery, and there were also some questions, and I'd like to see if I can clear up some confusion and a few things. One of the questions that was asked was about why the resistance varies with frequency, and the short answer is because it's not a resistor. It's actually a bunch of losses in the transformer, and I showed this circuit out of the ARRL handbook. If you want to know more about this, you should go to a source like that. There are lots of online sources that don't cost anything, so if you can't afford a book or something of that sort, try places like Wikipedia. I haven't the time to go do that research, but anyway, there's lots of sources on there. But the basic issue is this. What the impedance analyzer is measuring is, if you look at this channel of the oscilloscope, it's looking at a waveform, a sine wave. This channel is looking at a sine wave. So one way to think about it is there's a sine wave and another sine wave that's offset. And the difference between these is the phase delay. The difference between these is the amplitude difference. So it's checking the amplitude difference and the phase. In a vector diagram, what that amounts to is this. There is a z vector, and that vector is then decomposed into an r vector and an e vector, or an x actually vector. And this is the phase angle, the difference. Z is the magnitude. So basically, this is how you calculate R. Well, the problem is that as the frequency varies, both the magnitude and the phase angle change, and therefore, for example, at this point, the R is here, and at this point the R is here. So R will vary a lot, and remember, it's not a resistor, it's just losses. Another question that was brought up had to do with the this equation, and a comment that I may have misstated this in my verbal description. The equation here is correct, and if I said something different than this, then just ignore that and use the equation. The equation is accurate. In other words, you can use you can do one of two things. If you square both sides of the equation, then you get the square of this equals, and then this disappears because of the squaring equals the ratio of the ZS to ZP. So those were two things, and let's see, what was the third one? Oh, I know, people were asking about what they could do. Oh, by the way, if there's a key site, it's actually an original adjuvant that's been relabeled key site, impedance measurement handbook that Craig Hollabaugh was kind enough to put a link to on in one of the comments. If you need more on this, check out this impedance measurement handbook. What was the last? Oh yeah, one person asked what they could do in terms of, well, actually a couple of people asked if there was anything that they could do, and the answer is yes, absolutely. As you may notice, there is at least one person, his name I think is Abza, and also a person at Digilant, his name is Attila, who are actively working on this issue of doing a THD analyzer using the analog discovery 2. If there's any contributions you can make along those lines, I appreciate it. The other is, one reason that I especially emphasize Craig Hollabaw's website is, while I'm not going to have the time over the next few months, I was very happy to see that Craig has sort of picked up this impedance analyzer as a project. So I'm hoping that he'll be able to do more. But those are two areas. There are literally an unlimited number of possibilities. But if you have an analog discovery, get it out, try some things, and the area that I felt was being the problem that I was trying to make up for before I ran out of time was that the audio analyzer suite originally was available and did a great job. And then for some reason that no one is able to figure out, it just disappeared. It's no longer available. And I realized that left a lot of people in the lurch. So if we can, the new impedance analyzer does a great job in helping us analyze things like power transformers and output transformers. The other thing is that THD analyzer, and so I'm hoping someone will be able to continue that. And it looks like that ABSA and Attila are well on their way to solving that problem. So I still would like to try to finish that radio workbench, but I'm not sure I can. Don't look for very many more videos, and I probably won't be able to even read comments for at least several weeks. So in the meantime, I do hope that you've enjoyed these things, and I'm sorry for the length of this incredibly bad video, but I did want to get some of those points covered. So as I usually say, have a good day, and it's going to be a little bit longer than a day, I'm afraid. So anyway, hope you enjoy.